All right. Welcome everyone to Secret University's session where we'll be covering the secret counter box. Just a quick introduction. This is the team. It's me, Fuzzy Pizza. We got DDT, Professor DDT, who will be hosting the session today. And we also have Laura, Secret Chain Girl, and Alex Simply. We are very excited to be able to have this opportunity to teach and all the new developers that are coming into our network. And our mission has always been to make learning secret contracts as accessible as possible. So Secret University, what we started this past year, we launched as a platform that is able to host education content for all the developers. What we have prepared so far is what we call secret pathways. Secret pathways are basically courses that help developers accelerate their learning. They're written by secret developers themselves. And so far we have a getting started documentation on Secret Network, as well as Secret Contracts 101. But in the near future, we have a number of different courses coming up to allow for developers from any background to be able to start building on Secret Network, including front-end developers as well as contract developers who are looking to use the secret toolkits and also launch their dApp on the network end-to-end. All of our developers have the opportunity to also contribute back into the university by writing educational content and getting funded for it. And we also have secret boxes. So DDT, you want to go next slide? Secret boxes are mini projects that are hosted on a Gitpod environment that allow for developers to quickly learn conceptual learning topics by getting their hands dirty without needing to do the full setup of their contracts on local secret. And so we have a number of them also already on the platform, but today's specific one that we'll be going over would be the secret counter. DDT, do you want to kind of go over the secret counter and then take us away?
Sure. So the secret counter box is based on the secret counter contract. So it has a backend contract element as well as the front end. And the idea is it's actually based on the template which we typically use, where the idea is the functionality of the contract is very basic, but it does showcase how a contract can be put together and function with an app. And what this hopefully shows is how you all the basics required to design a contract and to build the contract. And if you want to add anything to it, this is often where you start as well. So this session will be mostly following what the box lesson goes through. So the course walks through the API, the functions required to make this work, as well as the interface with the app. And you still see my screen? Sorry, it seemed to have disappeared on my side.
Oh, yes, we can still see.
Okay, great.
We see this slide. We see this slide.
Okay.
So, right.
Great. So what is a counter box? I'm gonna just demonstrate what the box looks like, which actually seems to have the final functionality. And if I just stop sharing for a while and share my VS Code instead. So this is, if you open the secret counter box, this is what you would see on the app side. So this is what we're trying to create, where it's a very simple thing where you can press this button and just increase the count, or you can reset the counter. Right now, this is actually not connected to the contract. It's just fully front-end based. And the idea of the box is we have all the code that is sort of all the boilerplate and some code as well on the API that's already written for you. And the idea is with the box, we will guide you through how you can complete this and link this to the blockchain. It's mostly filling in the blanks and learning along the way. So what we'll do today is to walk through that process. We won't complete the entire box because that's the idea is we'll try to focus on the key parts of this box. And we might also veer off course here and there to talk about certain things which I think will be important for this session. So we will be quite hands-on, so I highly encourage you to download. Well, there are two ways to do this. You can either use SecretBox Gitpod environment directly, which is the easiest way and sort of the intended way as well with boxes. So all you need to do is to follow the link which we provided earlier, and that would lead you to the counter box. It will take a minute or two to load up, and you would actually see something quite similar to this, but also 3 terminals at the bottom. The other way is to download Please, so you can clone the GitHub repository and you can do this locally, which is actually what I'm doing here. So you would then see something quite similar to this as well. So I'll let you all do that while I continue talking so that you can code along as we go through this course. So let's start with the anatomy of a contract first. So from outsiders, non-contract developers, you can see a smart contract as a bit of a black box, or maybe more like a transparent box because the code's all open. So it takes some inputs, does stuff to it, and then potentially change the blockchain state or respond to the caller, quite often both. And for a contract dev, we are essentially designing this box. So when you look at a box, when you look at a contract, we need to then design all these different elements sort of separately. So what's the API, which is the inputs, the outputs, I suppose, and then how does the state change, which is also something which is quite maybe there's some differences on Secret Network, and then the response, which can be messages sent to other contracts or messages sent to the initial caller. Just some quick notes. We use COSM-WASM, secret COSM-WASM actually. So to design contracts, if you have used COSM-WASM, it would be quite familiar. But secret COSM-WASM is actually a fork of COSM-WASM 1.0 with some different features to suit the privacy angle of Secret Network. And in this case, we also have a front-end app, a very basic one, which is what you're seeing on the screen. We're using Vue.js, which is just a choice that we had for this box. You can use anything, but I think we're not really focusing so much on the Web2 element, but more the interface, which is based on Secret.js. So Secret.js is probably the standard way to interface an app with the contract, and that's developed and maintained by Secret Labs. So if you look at what the files in this counter box, which is, remember, the template, for the contract, you would see basically in the source folder, you'll see these files here. So these are what you'll be mostly editing. In any case, certainly for counter, but in almost any smart contract development process, this will be all the stuff in the source folder will be where you'll be coding. And the main ones in a basic contract are contract RS, message, and state. So this one is, if you know Rust, it's just a way to have this stuff here. An error is something which we added to modularize the error messages. It's not strictly necessary, but it's good practice. And for the front end, we have something called app here. This is more box specific. And we also have a source folder. And if you have programmed in Vue, you you would probably be quite familiar with how the folder structure is. But for our boxes, typically things would be in components. We have secret box here, for example, which is where this specific box code will be edited by you. Let's start with the contract, and then if we still have time, we would then do the front end as well. We mentioned there were 3 important files. So the contract, the message, and the state of files. So the message RS file is basically where we design the API. And this is a good place to start if you're not sure. So once a contract has been designed on paper, the specifications are written, and let's say if there's no strict rule where you start, but if you're unsure, the API is a great place to start, because typically it's good to see a contract, as I said earlier, like a black or transparent box, which non-contract devs might see it as. And the first thing that you want to design is the interface with this box. And this is where we have where we define all that interface. So a basic contract has 3 entry points. So we can instantiate the contract. We can execute messages. We can execute messages which change the state of the blockchain, and it's also recorded on the blockchain, so you can see these interactions. And then we have query messages where it's read-only interactions with the blockchain. In addition to those, we also have responses, and in this case, for the counter box, we only have we've only defined the response for the query. So the count response here is the response the contract gives for someone querying. But we can also actually have, in fact, we often have execute message responses as well. We can even have an instantiate message response. And we might maybe add some of that here as we go along. So what this is saying is this struct here for instantiate message would be what the person who creates, who first uploads the contract on the chain and then instantiate it, they would need to send a message in this structure. So it would be in this case, just one variable, which is count, and it needs to be for Rust sees it as an integer. If you're using secret.js, then it'll be a number. So in this case, what secret counter is doing with this is to take that input and the contract be instantiated with whatever that count is. And then execute message, here we have defined 2 things. So we use an enum. So in Rust, an enum allows you to have multiple variables. And in this case, the box already has 2 for us, so increment and reset. So let's say if you want to jazz this up a bit, you could add something. So for example, we can have something like increment by, which allows you to say increment by a certain amount. So you do it this way. So you just add any number of variants to execute message, and it will then define what the API is. And same for query message, you could just add something here, and it will then become part of the API. So if you have your editor open, you can add this. It's not part of the course, but it's just to show you how you change the API of a contract. For now, we can ignore most of these things up here. It's mostly to just add traits to the enum so that it can work in the contract. And I think one important note is, although all the variants here are written in camel case, the schema for the front end will actually be snake case. So that's what this thing is for. So in the JSON message that you send, increment by will be written something like this, just so you know. So I think that's it for API. If we have anyone in the audience with questions, feel free to ask now. Otherwise, we would move on to the next part.
Well, I just want to say that's really good. I like how you've likened it to an API on the contract with the messages. It's cool.
Awesome. So if we have time later, we will also add some response. We'll define the execute message response. But I think in the interest of time, let's move on to the next thing. So now that we've added increment by, you would notice that there's an error now. So there's a compiler error in contract, because that's a great thing about doing it this way. Because once you've defined how users should interact, the great thing about Rust is the compiler errors. Well, maybe it's a double-edged sword, but it kind of guides you in your dev work. So now it's saying the contract file now has this error. And if you move there, you'll see that the reason is because we've added a variant to the execute message, and it's saying here that we're missing that match arm to handle when someone sends that message. So here would be where we need to start coding in contract. But before we get to that, let's talk about how this contract file works. So this is where all your contract logic sits. So if someone sends, say, an increment message, this file is where you define the functions that manipulate that message, that does stuff with it, that changes the blockchain state and so on. So this is actually kind of the main file that you'll be working with. In a larger contract, though, you probably modularize it further. So you won't just have a single contract RS file, but you might have as many as you want, really. And in CosmWasm 1.0, if you have coded in that before, you'll know that there's this entry point macro here, which can be used for some of the entry points that's allowed in CosmWasm. And the basic ones, as I said earlier, instantiate, execute down here, and then query further down here. So as you can see in this contract, we have all three. So let's start with just handling this issue here. So we know that we added increment by, and we don't have the match on. So basically, all you need to do is to add that. And in this case, let's just do this, because we're not gonna actually go into that today. So now the error is fixed. So if you're following along or and have the box open, you'll notice that what it asks you to do is to fill in the gaps for each of these functions. So try increment has the function already here, but all it's doing now is basically when a message is received, it will then come to this entry point, execute. It will go through this match here, see that the message is increment, and then it will then execute this function here. And then this function here needs to be defined properly to actually increment our count. Right now, what it's doing is just printing this debug message and then just responding with a default function. So it's basically doing nothing right now, and we need to add the code here. So maybe just a note on what all these lines are. So this first line here is just defining the function. So the name here needs to match what's up there. So if you see what's here versus what's here needs to be exactly the same. Here we have several things we can add. So deps will be the dependencies. So it's basic CosmWasm stuff. So deps allows you to do certain things. So for example, actually, if you look at the source code here, so deps has three things. So it allows you to access the storage, what they call the API and the query. And there's quite a lot here you can explore. But for example, the API has things like humanizing an address, changing it to the canonical address, and so on. if we go back actually further, yeah, so it's storage as well is through dApps. So that's where you manipulate the blockchain state. There's actually environment as well up here, which we don't need in this case, but that allows you to access certain things like the blockchain height and so on. And the info would allow you to access the sender, which is actually really important if you're trying to validate a message. So if, for example, you have an owner of the contract, if they send a message, sometimes you want to allow certain functions or certain messages to only be used by the owner. So the message info will be where you check that the sender equals who the owner is. But in this case, we're not actually doing very much. So we just have dApps here. And right now, what we want to do is just these three things. So if you are following along, feel free to try to write the code here for incrementing. So what we need is to load the state, and the state had been instantiated here. You can see in the instantiate function. So we basically need to update it and add 1 to it. So I'm just going to wait for like 15 seconds and I'll start just typing that as well. In the box as well, you would see there's actually a solutions folder. So in case you're stuck, you would be able to see what the solutions are, which will be, I think, where is it?
Oh yeah, I think it's under
Laura
app.
will probably know where it is.
Yeah, under app, tutorial, and then solutions.
So if you're ever stuck, you can actually see all the solutions here. So we'll close this for now, but feel free to look at that if you're stuck. But obviously, it's good to try yourself first. So in this case, the solution is this, I hope. So there's an update function, and we'll talk about the state a bit more in a while. But it's immutable. So it should look something like this. I think that should do that. I think that's the solution that we have. Maybe something like that. So what this does is actually just a single step actually. So config, we'll talk about that in a while, but as you can see here, what we've done is to save whatever the state is, which the instantiator initiated. So that could be whatever the count is. So let's say if they started with count 1, down here we've updated the state to whatever that count is plus 1. So if this is all confusing, we're gonna talk about this config function here right now. But before we do that, let me just, yeah, I think we've covered everything here actually. So maybe we'll do that now. So this is actually done already. So when you're building a contract, this is quite a good sequence as well. You start with the message RS, fix that error, start writing whatever the functions are, and then typically any execute function would have some kind of state change, like in this case we do. So whatever this is doing, config is changing the state by adding 1, and we'll then have that third file, which is state RS, which defines all these things. So let's go there now. Before I'll just save this. Yeah, there's still some errors, but yeah, we'll deal with that later. So here, if you're looking at the counter box, you see that everything is actually already written here, I think. So actually, you don't need to do anything here for the counter box, but we'll talk about it anyway, because if you're doing, if you're actually designing and building a contract, you would need to, there's normally quite a lot of work on the state file as well. In this case, we are just using very basic storage solutions. In a different box, actually in a different pathway, we actually talk about the secret toolkit storage solutions, which have more advanced storage solutions dealing with more complex use cases. But in this case, we have a single thing that we want to store for our contract, which is this thing called state. And all it does is it stores the current count and the owner. So the owner is, if you look at the instantiate message, it's basically just whoever instantiated it becomes the owner here. So they'll be stored here, and then the current count. So we just have two things in our state. And we just use a singleton, which is the most basic core CosmWasm storage. So if you use CosmWasm before, you'll know what this is. Singleton basically just stores a single variable. So in this case, it's this struct up here called state. So what you need to do is to have first the config key, which needs to be unique for every different storage space you have. And then you need to define the struct or enum which you're storing. And in the case of a singleton, it's also good to have two functions for writing to this storage space as well as reading. So here, these are just quite standard functions where we'll say, what's the storage space, and then what's the type of what you're storing is, which is what we've defined up there. And singleton is something which CosmWasm storage, which is the core basic storage solution has. And you just have the config key here so that it minimizes errors if you do it this way versus trying to directly type the config key each time in the contract RS file. So these two functions, as you can see, takes the storage, returns this thing called singleton. So now if we go back to where we were previously, so because we've imported config here, further up, you can see we've got it here. So we've imported it from state so we can use it. So if you look at CosmWasm config singleton, it has several methods you can use. So update's one of them. As you can see at the top, save is another one. I think try load and load some others. And updating basically reads what's currently there and then save something different. So you have, as you can see, a function here, and what it's saying is, this was defining the type as you need to do in Rust if you're familiar with it. So as you can see, this works because we've defined it in the state file here. If you are using something more, if your contract's a bit more complex, singletons might not be the best solution. It can work for certain things like your contract configuration, which is why we have the word config here. There are other things like prefix storage, which allows you to store more complex variables. Basically, not necessarily more complex variables, but it allows you to have a prefix. So, for example, if you are like in SNP20, where it's the basic token on secret network, you would want to store the balances for every user. So a prefix storage would be a good solution for that, where you prefix each storage space by the address of the user and then the balance. So it's almost like having, in a way, many singletons prefixed by each space of storage is prefixed by the address of the user. So we will get more into that in some other boxes and some of our other pathways. But in this case, this is all we have here. We've basically covered all the main things here. If we go back to contract, actually, why is there an error here? Somehow it's not. Oh, because I didn't save. I didn't save my message. Yeah, there you go. So at the beginning, I was saying a contract takes some inputs, changes the state, and returns some response. What we've done already is to define what the API is, the inputs. We've changed the state here. So in this case, the response is just the default response. So it's just if this is successful, it would just return an OK and basically no information on what's happened, which is fine sometimes. But sometimes we want to handle, let's say, the increment by message here. We might want to return how much has been incremented by. So in that case, this response line here will be a bit more complex. Or if there's an error, we'll need to handle that as well, which is where this contract error thing comes in. So actually, if we go further down, reset here, this is where we actually deal with them. We need to deal with the error because the way we've specified the counter box is that only the owner can reset the counter. So if someone else tries to reset, it should return an error. So that is something which we'll do now. So I think the easiest way is just to copy this over. So right now, reset's doing the exact same thing, which is obviously not right. But let's see where we need to change things. So the first thing is the owner can reset the count to whatever he or she wants. So there's a count here, which if you look at the API, the message file again, reset has a count here. So first we need to change it to count. So now we set the contract state to whatever that count is. So that's the first thing we need to do. The second thing we need to do is to authenticate the message sender. So remember I said earlier that message info has the information on who sent the message. So we need to check that it matches this thing here. So this contract stores the owner, and that needs to match whatever is in the message info. This thing here doesn't change. The only thing we need to add is the authentication before we do the 2 lines below. So remember that it's the message info has the information. So what we can do is say if so info has something called sender. So it needs to sorry, maybe we'll do this instead. So if it's not then we return an error. Yeah, so we can, this basically solves it. So always saying if it's not equal, we return an error. And this error is actually defined in our error.rs file. So we have something called unauthorized here. And if you don't want to do that, you can also return a generic error. So oops, a generic error might be something like this. Standard error. Yeah. So you can just say You are not the owner. So that would work as well. Without that, sorry. Or maybe not. Yeah, that would work actually because we've defined the type, the return type to be contract error, which needs to be something in our error.rs file. So you just need to change this to standard error here, and it should work. But yeah, let's not do that now because we have our errors all nicely defined. So there we go. We have the increment function done. The try reset done. Let's not do the next one because we're running out of time. But basically, it's quite similar, except it's you use config read instead because it's a read only access to storage. So again, if any questions, feel free to ask now.
Oh, DT, is this the storage that's in the secret toolkit?
This is the basic storage that comes in. It's a core storage actually, so it's not. So we have something called COSM-WASM storage. So with COSM-WASM standard, which has most of what you need for COSM-WASM, and there's a separate package here called COSM-WASM storage, which has all these things like singleton, prefix storage, buckets, and so on. So we're using the basic stuff. If you want to use the toolkit, so we have something called secret toolkit, which has a storage package as well. We have something called item, which is quite similar to singleton. And the advantage of using item would be you have less boilerplate code. So you would just need this part here. So basically you just need this, a slight variant of these lines of codes here without having to define to write all these functions down here. So it's just easier. The disadvantage is, well, there's not much disadvantage honestly now. But when COSM-WASM, vanilla COSM-WASM first, I think COSM-WASM Plus has an item as well, and that was not part of their core package. It's still not part of the core package, and it was just not as mature it was just not as mature. So if you're concerned about that, you may not have wanted to use it back then. But the thing is, item in the toolkit is actually just based off what's in COSM-WASM Plus, so it's pretty safe. So it's a lot more convenient to use. And we can talk about storage more in another session maybe, but there are certain things which you cannot do so easily on secret network. So the toolkit also has certain solutions that helps you deal with that.
And so just so everybody knows, there is an educational pathway that goes over the secret toolkit that's on the platform as well. Thanks.
So we only have 10 minutes left. I'll just very quickly go through the front end. So we have another source folder in the app folder here. And if you go to components, secret box, you'll see this would be another area where the box would ask you to fill in the blanks. So right now we have the contract that's mostly done. The query is not done yet. The front end has two elements. So it has the standard Web2 stuff. So the HTML, the CSS, and JavaScript that any Web2 dev should know. But the difference here is there's the other category, which would be the interface with the smart contract. So we typically use Secret.js in our boxes, but I think there are some others you can use. But Secret.js is the most common. as I said, maintained by Secret Labs as well. So what you need to do here is to link that front end app that we had previously here, the browser. Right now, it's all front end based. We need to link this to the contract. And the way that's done is for to use Secret.js, and you need to basically do two things in this box. One is to create the secret network client, and the second is to define the interface, the functions that will interface with the contract. So again, I don't think we'll be able to do all of this today, but solutions here would have the secret box here as well. Right now there are errors because it's not placed in the correct place and we've not installed all the dependencies. But if you want to complete, which certainly encourage you to complete this box, we have the tutorial which walks you through what to do. So try that first. If you're stuck, the solutions are here. But there are basically two places where you need to add code. So here you need to basically create a secret network on instance. And then further down here, you'll be creating the interface. Actually, not there, it's here. We've already got the functions here, but right now it's all front-end based, as you can see. Maybe I'll actually just very quickly walk through the solution in a couple of minutes before we wrap this up. So actually, as you can see here, this is some of the additional stuff. So we first create this new variable here, wallet. This is the so in local secret, if you go to our pathway 101, if you need to understand what all these things are, but local secret is something which we typically use when we are developing. So it's a local instance of the secret network blockchain that you can launch locally and interact with it. It does have 4 wallets that it creates with secret balance that you can use, and this will be I think for wallet 1. So if you go to the docs, you'll see all 4 of them. But it's a 24-word seed phrase that you can use to create your first wallet and actually all 4 wallets. This thing here is box specific. So when a box is launched, what we've done is basically we'll create the local secret instance, and we will have all these variables in the environment so that you can just use it straight away. It's just for your convenience. So you need to add this so that you know basically what the contract code is, the hash, which is something that's stored on chain, the address, and the LCD URL to interact with the blockchain. Here is where we create a new instance, the client. So this is just how you do it. You need to define the URL, the chain ID, secret dev 1 would be for local secret or the testnet. For mainnet, this will be different. And with this, you can then use this wallet that we created here. And then we'll just go through one of these functions. So we've added, in this case, just inline, created a new type here. If you're trying to do it in a scalable way, you probably want to modularize it. And this is how you can use Secret.js to query something. So it's just query compute and then query contract, and then this is where the message that we've defined the contracts here. So maybe get count is not something which we actually did just now, but you can see here increment. So the message, you need to change this part. So if you're using this as a template, all this can be just copy and pasted. This will be changed to whatever your contract API is. And then here you can see that we change the value to whatever this returns. It needs to be asynchronous, so you need await here. And so what my sorry, actually what I just said just now isn't quite right. It sends this message which changes the state, and then it returns this value, which actually is just a query of the contract. So I think we only have 3 minutes left, so I'll end it here. And I think Fuzzy has some closing remarks.
Yeah, do you mind going back to the slides at the very end?
Sure.
Yeah, so this is just one of the demonstrations of one of the boxes specifically for Secret Counter. Again, we have multiple secret boxes also available. The next one that we have a session on during the Hack Secret will be Richie Rich, which is more of a DeFi vertical box that teaches you how to use viewing keys and permits. And then next slide. Yeah, so I know a lot of you will be watching this offline during your own time. Once you've finished reviewing this video and you want to try out the Secret Counter on your own, or any secret box for that matter, go to the SU General channel on Secret Networks Discord and drop us a message to see how your progress is going. And if you have any questions, we'll be there to help you respond. As well, you can also explore the remaining of Secret University to check out bounties and also look to be a contributor. In order to become a contributor, you can go on the platform and connect to the platform as well. And it'll help you track your progress of what you've done in the network and also what you are contributing for your content. And then finally, there are many secret bounties are available for our network. That are available for secret funded grants. That's available on scrt.university/bounties. And these are hosted by both Secret Labs as well as other community members that have approved certain projects. So again, thank you for joining our session. We are very excited to be able to help teach the next generation of Secret Network developers. And we definitely check out our platform. We made it for our community to be able to learn. And so from this Secret Counter box, we hope you have learned a lot in terms of how to launch your own secret DApp. All right, any last words?
That was excellent.
Yeah, it was awesome. Thank you, DDT.
Yeah, thank you, DDT, Darren.
Thanks, DDT.